Okay, guys, I'm going to run through sections 2.1 and 2.2. I don't think I ever made a video for you on this, so I'm just going to go through it real quick. Um, Analytic geometry, that's Rene Descartes. I'm not going to run through this part because you can look it up. The XY plane, I think you probably know all this, but this is what Rene Descartes came up with. It's called the coordinate plane. It's also called the Cartesian plane because it's named after Descartes. Two perpendicular number lines, obviously the x and y axes, they intersect at a point we call the origin. 0, 0 is the origin in the xy plane. The coordinates of the origin, I just said, are 0, 0, and every other point in the plane has coordinates x, y, which give its location with respect to the origin. The x coordinate comes first and indicates the horizontal distance from the origin, and the y-coordinate comes second and indicates the vertical distance from the origin. Okay, the distance formula, remember that we could use the Pythagorean theorem to find the distance between any 2 points. What we have to do is just draw a horizontal line from the horizontal location of the first point to the horizontal location of the second point, and then a vertical line from the vertical location of the first point to the vertical location of the second point, and then we can count the number of spaces or units that are the sides of the right triangle. The distance between the 2 points is the hypotenuse. So in this one, we have -2, 3, and 4, -4. You can see that the horizontal distance between those 2 points is just the difference in the x's. So that's 6. And then the vertical distance between those 2 points is the difference in the y's. So that's 7. And if we use the Pythagorean theorem, we have the sum of the squares of the 2 legs is equal to the square of the hypotenuse. So that's 36 plus 49 is equal to the distance squared. So that is 85 is equal to the distance squared. So the distance is going to be the square root of 85, and the square root of 85 cannot be reduced. If we wanted to determine if the given points form the vertices of a right triangle, what we can do is find the distance between each pair of points and see if those distances would work in the Pythagorean theorem for a right triangle. So to know, so if this side is A and this side is B and this side is C, we want to see, does A squared plus B squared equal C squared for this triangle? And if it does, we know that this would be a right triangle. So to do that, we just use the distance formula to find the distance between A and B, and that'll be the length of A, and then we'll find the distance between B and C, and that will give us the length of BC, that other leg. And then if we find the distance between A and C, that will give us the length of side C, which looks like it should be the hypotenuse. So we'll just do that real quick. So we'll find the distance between A and B, and that'll give us A, little a. So the square root of -2 minus 2, quantity squared, plus the difference in the y's, 1 minus 5, quantity squared, is going to be the square root of 16 plus 16, which is the square root of 32. And I'm not going to reduce that because we're going to square it anyway, so we might as well just leave it the way it is for now. All right, so B, difference between the B and the C, the distance between the B and the C will give us that leg of the triangle. And so that's difference in the x's, quantity squared, plus the difference in the y's, quantity squared, is going to be the square root of 9 plus 9, which is the square root of 18. And then C, distance between points A and B. So the difference in the x's is -2 minus 5, quantity squared. And then difference in the y's is 1 minus 2, quantity squared. And that's going to give us the square root of 49 plus 1, which is the square root of 50. And you can probably already see that A squared plus B squared does equal C squared, because A squared is 32, B squared is 18, and then c squared is 50, and that is true. So it is a right triangle because its sides work in the Pythagorean theorem. All right, the midpoint formula. If you want to find the midpoint of any segment, you just look at the endpoints and you take the average of the x coordinates and the average of the y coordinates. So if you wanted to find the midpoint of a segment connecting 4.2, -4, and -2.83, that is exactly what you would do. You would add the x coordinates and divide by 2, and you would add the y coordinates and divide by 2. And that's going to give you the midpoint. So 4.2 minus 2.8 is going to be 1.4. And -4 plus 3 over 2 is going to be -1/2. And so that is going to be 0.7. And I'll just write it as a decimal since I wrote the first one as a decimal. And so that's going to be 0.7 -0.5 for the midpoint. All right, graph the following equation, and we're going to do this by plotting points. So we can just choose some x's and see what we get for y. So I'm going to choose 0 for x, and that's going to give me 0 minus 1, which is -1. So I'll plot that point, 0, -1, right there. And I'll pick 1 for x, and that's going to give me 1 minus 1, which is 0. So 1, 0 is on this. And then I'll pick -1 for x, and that's going to give me 0 again. And so it looks the same way on that side of the y-axis. If I choose -2, I'm going to have 2 minus 1, which is 1. So -2, 1. Let's see, let's put in 2. 2 minus 1 is 1. So you can see it's symmetric about the y-axis, and it looks kind of like it must be a V. Now, we don't, just by plotting points, we might not realize that that's what it looks like. We might think it's a parabola, but I know that it's an absolute value function, and you do at this point too. But this is showing you a little bit why plotting points is not always going to help you make an accurate graph. All right, so finding the x and y intercepts of a graph is a good thing to do, especially when you get to more complicated equations. And to do that, to find the x-intercepts, you're going to set y equal to 0. So we have this equation again, y equals the absolute value of x minus 1. If we set y equal to 0 and find out what x is, then that'll tell us the x-intercept or the x-intercepts. And so if we add 1 to both sides, we're going to have 1 equals the absolute value of x. And if 1 is equal to the absolute value of x, then we know x must be either 1 or -1, because the absolute value of 1 is 1 and the absolute value of -1 is 1. So x is going to equal 1 or -1. And so the x-intercepts for this are going to be at 1 and -1. To find the y-intercepts, you set x equal to 0. So the equation y equals absolute value of x minus 1. The y-intercepts are going to be y equals 0 minus 1, absolute value of 0 minus 1, and that's -1. So it crosses the y-axis at -1. Okay, moving on to circles. In our study of analytic geometry, also called coordinate geometry, a circle is a set of all points x, y that are equidistant from a fixed point hk called the center. This is the definition, bottom line definition of a circle. The distance from any point on the circle to the center is called the radius. We know how to write the equation of a line given its slope m and y-intercept b. So how do we know how to write the equation of a circle? That's a similar situation. You have two characteristics of a circle, and if we can write the equation of the circle in the form we want, we'll be able to quickly see the center and the radius, and that'll let us graph the circle. So here is how you understand the standard form for the equation of a circle. If you have a circle with radius r and center hk, you can use the definition of radius to write the equation. So the radius r is equal to the distance. So the distance formula is what's going to happen right here, from any point on the circle to the center. Any point on the circle, we would just call it xy, and the center we have called hk. So the distance from those between those 2 points is x minus h quantity squared plus y minus k quantity squared. If we square both sides of that equation, we have r squared is equal to x minus h quantity squared plus y minus k quantity squared. And this is the standard form for the equation of a circle. It just comes from knowing what a radius is. And so usually we write it with the binomials on the left side and the radius squared on the right side. So that's what it looks like. All right, so write the standard form of an equation of the circle with center -4, 6 and radius 2. So we just write exactly what we just said. X minus h is x minus -4 quantity squared, and then y minus k. So y minus 6 quantity squared, and that equals the radius squared. And so you can write this x plus 4 quantity squared plus y minus 6 quantity squared equals 4. That's a fine way to write it. It's not exactly standard form. This is exactly standard form, but I will accept that because it's just easier to read. All right, so write the standard form of an equation of the circle with endpoints of a diameter, -1, 0. So -1, 0, and 3, 4, right here. So if those are the endpoints of the diameter, the center must be right in the middle. All right, so to find the midpoint of that diameter, we just take the average of the x's and the average of the y's, and that is going to be that midpoint, which is the center of the circle. So that's 1, 2. That is the center of the circle. 1, 2. So 1, 2. And then I can see what the radius is by finding the distance between the center and the endpoint of that diameter. So the distance, so this is the center. The radius is going to be the distance from 1, 2 to one of these endpoints, either -1, 0 or 3, 4. And so that's going to be 1 minus -1 squared, and then 2 minus 0 quantity squared. And so that radius is going to equal the square root of 2 squared, which is 4, plus 2 squared, which is 4, and that's 2 square root of 2. And so to write the equation in standard form, we're just going to write that x minus 8. So the center has an x coordinate of 1, so x minus 1 quantity squared. And then y minus k, the k for our center is 2, so 2 squared, and then r is 2 squared root of 2. And if we square that, we're going to have 8. All right. The general form for the equation of a circle is x squared plus y squared plus ax plus by plus c equals 0. So given the standard form of a circle, center radius form, so that is this form. So we're going to multiply all that out, and we'll have x squared minus 2x plus 1 plus y squared minus 4y plus 4 is equal to 8. And then if we get everything on one side, we'll have x squared plus y squared minus 2x minus 4y plus 5 minus 8 is minus 3 equals 0. Write the equation of the circle in standard form and then identify the center and radius. So here we have it in general form. We want to change it to standard form, and we're going to do that by completing the square. So we'll put our x's together, x squared plus 10x plus blank, and then plus y squared minus 6y plus blank. And then I'm going to put the 25 on the right side of the equation. Now, to figure out what we put in the first blank, it's 10 divided by 2 squared. So 10 over 2 is 5. Square it, you get 25. And then we've got 6 for our y coefficient here, or -6. We're going to take half of it and square it. So 6 divided by 2 is 3. Square it, we get 9. Now, since we added 25 and 9 to one side, we have to add it to the other side as well. So x plus 5 quantity squared plus y minus 3 quantity squared is equal to 9. And so our center, remember, the x plus 5 is x minus -5. And remember, in the standard form, there's a minus sign here. So we have to think about it in terms of that. So we would write x plus 5 as x minus negative 5. So the x coordinate of our center is negative 5. And then y minus 3 has a minus sign. So 3 is the y coordinate of this center. So this is the center. And then the radius is going to be the square root of 9, which is 3. Okay, one last thing, just because an equation is of this form doesn't mean it's necessarily a circle. It could be something different. So write this equation in standard form and see what happens. If we said x minus 0 squared, because there is no x term, there's just a x squared term, and then plus y squared minus 14y plus blank, we have to complete the square for that one. And then we've got the negative 49 on the right side. So in that blank, we're going to put half of 14 and square it. So 7 squared is 49. We have to add that on both sides. And so then we've got x minus 0 squared plus y minus 7 squared is equal to 0. All right. So if that were in the standard form of a circle, that would tell us the radius is 0. Well, radius can't be 0. So that's not a circle. But what is it? All right. Well, we have two things that are squared being added together to get 0. Well, anything that's squared is positive or 0. So the only way we could possibly get 0 here would be if both of these binomials were equal to 0. And for that to happen, x would have to be 0 and y would have to be 7. And so the point 0, 7 is what this equation represents. There is just one solution, and that is 0, 7. And so basically, here's the bottom line on this. If we have an equation x squared plus y squared plus ax plus by plus c equals 0, and we write it in the form x minus h quantity squared plus y minus k quantity squared equals c, if c is greater than 0, which is what we've been seeing so far, the graph will be a circle with radius square root of c. If c is 0, then the graph will not be a circle. The graph will be a single point. If c is less than 0, then the graph will not be a circle. There will be no graph because the solution to the equation is the empty set.